All right, let's get right into a truly massive shift happening in the world of AI today. We're all pretty used to AI doing a cool little trick by now, right? Like generating a funny meme with a slightly weird background, or writing a quick 5-line poem. But what we're looking at here is a move away from those novelty apps. We're heading straight toward rigorous scientific AI operating systems. Specifically, we're talking about something called deterministic orchestration. Now, take a look at this. There's a fundamental contrast between two totally different ways of thinking about AI development. On the left, we have the master's mindset, which basically just asks, hey, can you build an impressive system? And look, that's a great engineering goal. But the PhD mindset over on the right takes it a step further. It asks, what new knowledge about computing did this research actually produce? That is true scientific discovery. It's not just about wiring together a bunch of AI nodes to see if a pipeline magically works. It's about fundamentally understanding the science of how they interact and creating entirely new computing knowledge along the way.
Which brings us to part one, the engineering versus science shift.
So the core focus of this research, it isn't just about throwing billions of dollars at massive warehouse-sized server farms. Not at all. It's actually about the science of orchestrating multimodal AI, meaning AI that handles text, images, video, and audio, and doing it right on commodity consumer hardware. Yes, everyday computers. We are moving way beyond simply adding more nodes to a workflow. Instead, the focus is on coordinating multiple, completely independent generative AI models without, melting a standard desktop computer. That takes us to part two, framing the right questions. Right, so this is where so many developers end up getting stuck. The old binary question was usually just, can AI make a movie? Well, that's a yes or no question, and it doesn't actually teach us anything about the underlying mechanics. The new scientific question we absolutely need to be asking is, how should multiple AI systems cooperate? Instead of a simple can it do it, we must investigate how these highly complex, completely disparate systems actually work together in a synchronized, reliable way. For instance, how on earth can multiple large language models maintain long-term narrative consistency? Think about it. If you've ever used an AI chatbot, you know it might completely forget your name 10 minutes into the conversation. So for generating a massive long-form story, how do we stop the AI from just totally rewriting history halfway through when we pass the story across different models? And then let's look at the visual side of things. How do independent image and video generators actually share a semantic state? If one AI generates an image of a character's really messy bedroom, and then a completely separate AI is tasked with generating a video of that character walking into the room, well, how do we make absolutely sure the bed is in the exact same spot in both outputs?
But most importantly, how can orchestration remain deterministic while using stochastic models? This is a huge one. Think of generative AI kind of like a jazz band. It's inherently unpredictable. It's random. It's improvisational. That's what stochastic means. But an operating system, that needs to be like an orchestra reading sheet music, completely reliable and deterministic. So how do we force predictability out of that chaos, while minimizing those weird, hallucinated inconsistencies that completely ruin the experience? Let's dive into part three to find out the orchestration architecture. Enter the semantic ledger. Basically, instead of letting every single individual AI model invent its own wild version of reality, this introduces an immutable, shared state. You can think of it as a master script that every AI actor and camera operator is literally required to read from. That way, nobody goes off script and hallucinates. And because they're all working from this single, unified source of truth, the world they build remains perfectly consistent. And that ledger, it's supported by a really precise framework. To keep everything locked down and deterministic, we use semantic locking to freeze visual and narrative details right in place. Then, hierarchical planning structures the whole creation process from the top down. We also have adaptive model routing, which acts sort of like a casting director, sending specific tasks to the absolute best AI model for that particular job. And wrapping it all up, everything is tightly governed by resource-aware scheduling. This keeps a very close eye on strict GPU memory limits, ensuring dynamic allocation doesn't just crash your machine. When you put all of that together, you get the virtual AI studio. It's essentially mapping computer science directly onto filmmaking. You've got multi-source fusion, bringing the story elements together. You have a dynamic cast, where characters act as reusable semantic entities rather than random morphing generations.
You've got a camera director AI making actual deliberate choices about cinematic language. And running the entire shebang is the adaptive model scheduler, acting as your ultimate tireless studio executive. But wait, a real studio doesn't just shoot a single take and release it without editing, right? Well, this system features a continuous self-evaluation loop. It literally acts as its own harshest critic. So instead of just clicking generate and calling it a day, the system generates the output and then relentlessly critiques its own work. It actually researches exactly how many continuous iterations are required to maximize the quality before finally presenting you with the finished cut.
Moving right along to part 4, cross-media narrative grammars.
Now, this is where it gets truly wild. A single story might start its life as a simple text-based novel, but from there, the system sequentially evolves it through an entire chain of completely distinct media formats. It translates it into a radio play, then into a film script, then a comic book, an interactive story, and finally ends up as a live interactive news report. The system is fundamentally altering the format, but keeping the core narrative completely intact. Which, of course, poses a massive research problem. How do narrative semantics survive across such diverse media? Look, we've all seen terrible movie adaptations of our favorite books. When a story jumps from a novel to a comic book to a news report, how does the system computationally guarantee that the soul, the tone, and the essential details of the story actually survive the translation? To solve this visually in 3D, the system totally abandons unplanned generation. It just throws out that chaotic, random camera movement and stochastic behavior we're all so used to seeing in AI videos. Instead, it relies on orchestrated generation. The AI actually uses a planned 3D motion graph and symbolic operators to mathematically plan out a perfect camera move before a single pixel is ever even rendered. It's a real game changer.
Let's look at part 5, evaluating autonomous AI production.
Because a true scientific approach requires hard data. It's no longer enough to just look at an AI generation and say, yeah, sure, that looks pretty good. We have to mathematically measure character consistency across different scenes. We have to measure overall story coherence. We rigorously evaluate camera diversity, check whether the cinematic language makes structural sense, and ultimately validate it all with actual user preference scores. And remember, because this is designed for everyday commodity hardware, we have to heavily monitor the quantitative system metrics too. We're tracking the render success rate, we're monitoring VRAM utilization to make absolutely sure we don't crash the machine, we track recovery times after system failures, and crucially, the literal exact cost per finished minute of media. All of this proves the system actually works in the real world. So, all of these architectural contributions, the ledgers, the operating systems, the evaluations, they all culminate in one powerful, unified thesis: semantic orchestration of resource-constrained, multimodal AI systems for autonomous long-form narrative generation. Okay, I know, it's a bit of a mouthful, but it perfectly marks the death of the simple AI gimmick and the birth of a rigorous scientific production system. Which leaves us with one final exciting and, okay, maybe slightly terrifying thought to wrap up this explainer. If this is what happens when we apply deterministic orchestration to AI on standard, everyday hardware, what happens to the future of media when AI officially becomes an autonomous producer? The sheer scale of what these autonomous production pipelines will achieve next is just staggering. Thank you so much for joining me for this explainer, and I'll leave you to think about that.